If we think about the periodic table for a minute, it's going to look vaguely like this. So you're going to have hydrogen over here, you're going to have helium over there, you'll have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, and then we'll fill in some more as we go. That is, the periodic table has a bunch of columns and a bunch of rows, and those are actually extremely useful to us in identifying what to expect from different material. And so first and foremost, let's talk about the columns. Way over here on our leftmost, this is our alkali metals. The alkali metals don't actually include hydrogen. Hydrogen is an exception to a lot of things, but lithium, sodium Na, potassium K, and the rest of that column, those are the alkali metals. They are if you ever have the metal, it reacts with water, catches on fire on contact with water. So rubidium and cesium, rubidium, cesium, and francium if you want to do it. Lithium will bubble and sputter around the surface, sodium will catch fire and sputter around the surface, potassium K will actually explode, and then rubidium and cesium will also explode, just much more violently. These metals don't actually exist on Earth. We have to make them. Not easy. You end up producing toxic chlorine gas and molten sodium metal, and you have to have molten sodium chloride, so table salt, in a vacuum chamber. It's not easy to obtain these. Not as pure substances. Which is actually what we're here to talk about, because generally what will happen is if you find them on Earth, they are actually charged. They have a +1 charge. And so think back to our symbols for a minute. When we had a symbol, there was that upper right, which was the charge. So you could have things like Cl-, Na+, H+. That upper corner told us what charge. You can even get things like Mg2+. There can be, depends on the atom, there's different charges. That column, the alkali earth metals, if you find them, they will be +1. That is how they show up in nature. If you go to the next row over, you have the alkali earth metals. So as you go down the row, beryllium, magnesium, calcium, strontium, barium, and the like. That row, you will find them as ions, which is the term for having a charge. You'll find them charged on Earth. As a result, you don't expect them to ever be pure magnesium or pure calcium. You can make it again, but it's not easy. Instead, we tend to find these as +2s. So if you look over here at magnesium, you'll notice I gave it a +2 charge. It is in the second column from the left. It will always have a +2 if we find it loose or out in nature. Jumping over to the right, we have helium, neon, argon, krypton, xenon. The far right is called the noble gases. The noble gases have a charge of 0. We don't expect them to ever have a charge. You can make them, but it takes big lasers and lots of energy. They don't do it on their own. If you ever find helium in nature, it is 0. It is neutral. If you ever find argon in nature, it is 0. It is neutral. Moving in one row, though, our fluorine, our chlorine, our bromine, our iodine, and so on. These are the halogens. So HALOGN. The halogens are always expected to be -1 if they're charged. Again, we can make them not charged, just take special situations, the same as the metals over on the far left. Shortening down our list real quick, oxygen, sulfur, selenium, we expect them to be a -2. The nitrogen and the phosphorus we expect to be a -3. And the rest of the periodic table we'll leave for later. We don't really expect charges on the carbon or the boron. And the section in the middle here I've left blank is the transition metals. We will discuss them ideally at the next class, but it won't get called out here. So part of what the periodic table does is it groups elements together by common behavior. And so by knowing what we expect each column to do, very quickly I can find the charge I expect on an element. So if I was to ask, what is the charge on a sulfur? Well, we could go and we could look at sulfur over here, and we could say, hey, it's in column 2, so a sulfur should have a 2- charge. I don't have to memorize this, though eventually we will from habit. But I can look at the table and reference to say, oh, it is 2 in from the noble gases. First is -1, then is -2, then is -3. And so I'm able to identify that charge very quickly.